Thank you, Tim. And after that introduction, it's only downhill from here on. I'm excited to be here. I've known Eric for a long time, and I'm a big fan of CICC. And I couldn't say no for this opportunity. What I would like to do today is talk to you about low dropout regulators. Because this is an EdSession, hopefully at a level that everybody can follow, and also hopefully when you read other advanced stuff, it would make a little bit more sense than it does now. For instance, I think this is recorded, so I don't know the rules for asking questions. Maybe you can ask me at the very end if that is not a problem. So let me briefly spend some time so that everybody is on the same page. First of all, this is what I think of as the role of a low dropout regulator is. In a typical power management system, what you have is a DC to DC converter shown here, which provides most of the power, and then you have many circuit blocks that needs to have supply voltages that meet certain requirements. For example, if you take analog and mixed signal and RF, the power supply noise is an extremely critical parameter, and we'll talk a lot about how to suppress power supply noise in the output of the LDO. And in circuits where you have a lot of switching, for example, digital circuits, isolation also becomes important. You don't want, for example, if this is a large digital system, you don't want to have any of the switching noise appearing or coupling to the output of the DC to DC converter. In that case, we are interested in reverse isolation. Right? So, so in principle, a good low dropout regulator must satisfy essentially these three requirements. It should suppress any ripple produced by the DC to DC converter, and it should provide some isolation between noise generated by the circuits to the output of the DC to DC converter. And in applications where supply noise is of critical importance, it should take a noisy input, in this instance supply voltage, and provide a clean supply to the sensitive circuits. What I'm not showing here is one other case when this is battery voltage. If this is a battery voltage, the regulation is primarily done by the DC to DC converter. In some applications, the battery voltage might itself be an input to the LDO, in which case there are a few other considerations that we need to pay close attention to. But this is the context in which I'm going to talk about design and the intuition behind the design of low dropout regulators. Okay, so one easy way to actually implement a low dropout regulator is, for example, if this VIN is not the VIN that you are looking for, then one could possibly use a simple resistive divider and generate an output that meets the required ratio between Vout and Vin. And clearly, this is not good, but I just wanted to show that a good place to start is the simplest thing, and I couldn't find anything simpler than a resistive divider. The problem with this is if the load current changes, the output voltage changes, and as a result, this is not really providing the desired output voltage. So in that case, one possible way to regulate the output is to simply change the resistor divider. Right? You change the resistor divider using, well, I'll show in the next slide, using some kind of feedback, such that the output remains some fraction of the input at all input voltages, right? So feedback regulates are in such that Vout is some fixed value, fixed being some desired reference voltage. So this is how almost all the LDOs are implemented. You choose your variable resistor, maybe an NPN or NMOS or PMOS. We'll talk about these. I'll refer to as pass devices. There are many choices for the pass devices, which we will discuss shortly. And this is the simple feedback loop. So the feedback loop now is forcing the output voltage here, or the fraction of the output voltage to the reference voltage. And if this feedback is good enough, then for any values of these RLs, your output is going to be some beta times Vref, regardless of the output current. Right? So at a very high level, that's at least minimum requirement that an LDO should satisfy. Right?